Okay guys, we're going to start chapter 2. In chapter 2 we're going to really get into looking at graphs and talking about how we can use graphs to help us analyze different statistics. So this first section 2.1 is looking specifically at numerical data. And so a couple of key objectives for this section. One is to explore the distribution of numerical data, and then to look at how we can represent numerical data using dot plots, histograms, and stem plots. So what is the distribution of a sample? So remember, any collection of data will have some sort of variation within that data, and that's what we're interested in looking at. So what we would start with is something called the sample distribution. So the sample distribution gives us the frequencies of a range of different outcomes that could possibly occur for a sample. What does that mean? So basically think about this. If we take a sample of data from a population, remember we're looking right now at numerical data, and we want to look at that data visually and see if we can make some sense out of it that way. And that's what these graphs we're going to get into in a little while, those are going to help us do. There's three main components though that you want to always remember when you're talking about numerical data. So the three components that you're interested in are the shape, first of all. So literally, what does it look like? So let me write that down. So how does the graph look visually? Is it skewed in one direction or another, or does it tend to be symmetric, or most of the data is in the middle and then kind of taper out? And we'll talk more about that as we go. The center, that's the next thing you want to look for. So the center could be thought of as a typical value. So what value for that sample is representative? This might be thought of as the average or the mean, and there's some other measurements we're going to get into. But what is a good representative for that sample data? That would be the typical value or the center. And then the variability is literally the variation. How much variance is there from one data point to the other? If we're looking at a graph, we can think of it as the horizontal spread. And another term for this that we might use is the variability. So literally, how spread out is that data when we look at the graph? Are the data points far away from each other, or are they fairly close together? All right, so below is the data. Here's an example. Below is the raw data for the number of games played by a sample of professional female soccer players during a given season. And I've got them here sorted in ascending order. And I've used StatCrunch to sort these in ascending order, and we'll talk more as we go about how to use StatCrunch to help us with these graphs. Most of the time, I shouldn't even say most of the time, I think pretty much all the time, if we have to make a graph, we're going to be using StatCrunch to help us do that. So a couple of things to observe. The distribution records all observed data values. So these are all the values we have for our sample that we observed. And it's often difficult to see patterns looking at the raw data. We mentioned this back in chapter 1. Looking at the data raw is usually not helpful. We want to be able to do something with this data in a way that can help us analyze it. So one way to do this would be to use what's called a frequency table. So a frequency table lists all data values. So let's write that down. All data values with their counts. And sometimes you can see patterns from this, sometimes you can't, but the frequency table at least kind of helps you get the data organized. So the frequency table, for example, 2.1 would look like this. So where am I getting these numbers? The value is the number of games played by each soccer player. So we have, for example, we have a player that played 1 game, we have a player that played 2 games, a player that played 5 games, and so forth. But what I want to record in each little box there is the frequency. So if you go back to the data above, how many players only played 1 game? And you can see from up here, there were 3 players, so we're going to put a 3 there. And then, let me try to write that a little bit better. And then, how many players played 2 games? So if you look back at the data, it looks like we only had 1 player play 2 games. We had 1 player that played 5 games, 1 player that played 6, 1 7, looks like 1 8, 1 9. We had 2 players that played 10 games during the season. Looks like we had 1, 2, 3, 4 players that played 11 games. Let's see, 1, 2, 3, 4 players that played 12 games. 2 players that played 13. And let's speed this up a little bit. I think you probably get the idea. 15, it looks like there were 2. 16 was 1, 17, let's see, 1, 2, 3, 4, 5, 6. 18 won 2 players, and then 19, we've got 2 players, and then 20, we've got 2 players, 21, we've got 3 players, and then 22, we just have 1 player, 23, we've got 2 players, and then 1 for 24 games. And actually, I think there's a typo here. The highest number of games one of the players played was 35. The table it says 25. I think this should actually say 35. So make that correction in your notes, but we had 1 player that played 35. So the number of frequencies, if we take the frequencies, that should add up to the total number of soccer players that we have. And we're going to trust that it does right now. All right, we're going to come back to the soccer player data in just a moment. Let's go ahead and go to the next page. So what could we do with this data? So we have the soccer player data. We've got it organized into a frequency table, but what can we do with this to get a sense of what the sample distribution looks like? So what we're going to do is we're going to talk about 3 ways we can visualize a numerical distribution, and those would be dot plots, histograms, and stem plots. So in examining distributions, we use the following 2-step process. So first, visualize the data. And by visualize the data, what we mean is use a picture. All right, so use a picture that effectively summarizes the data visually, and that's what we mean by creating a dot plot, a histogram, or a stem plot. That's going to give us a picture of the numerical distribution. Various visual representations capture different aspects of the data, so sometimes a dot plot or a histogram might be better than a stem plot or vice versa, but the graphs must do 2 things. They must record the data values that are in the sample distribution. Sorry, this is a little messy. Let me write this up here. Data values that are in the sample distribution, and they must indicate the frequency of each of those data values, which is why that frequency table may be helpful in getting our distribution set up. And then the next thing you want to do is summarize the shape of the data. So that goes back to what we talked about earlier, those same 3 things you always want to look for when you talk about a numerical distribution: the shape, the center, and the spread. This is going to come up over and over again throughout this chapter. So remember, the shape, and what we usually look for is one of 2 things. Is the data symmetric? So do most of the data points fall in the middle and then kind of taper out? Or is the data skewed one way or another, either skewed right or skewed left? And we'll talk more about this. We'll see some examples. The center, is there a common or typical, that's another word, typical value that represents the data? Typical value. And then finally, the spread. Are there data points, so are data values far away from the rest of the data? Or are most of the data values tucked in closer to the center? So those are the things we want to look for when we have the distribution in a graph format. So let's first talk about a dot plot. So a dot plot records the data values on a number line with a dot above each number representing the data value that's observed. And so I've got a picture here of a dot plot. Now this is taking our soccer player data, so the same data we had a few minutes ago with the number of games played for our soccer players, and we're using StatCrunch to do this, and to have StatCrunch create the dot plot for us. So I have instructions here in the box that show you how to make a dot plot in StatCrunch, and we'll go over this in class. So I'll show you again how to use StatCrunch to make these graphs. It's really pretty easy, but for now I want you to just take a look at the dot plot and think about what you observe by looking at this graph. Remember we talked earlier about center, shape, and spread. The shape here, there's not a lot we can say right now about this, but I would say the center, you can think about visually, where is the center of the graph at what number? So I would say the center is probably somewhere right in here. And you don't have to give me an exact answer for the center. That can be a little bit subjective for right now. We'll get more concrete ways to describe some of these later on. But for now, we could say that the center of the data is somewhere in the little range of between, I would say maybe 15 and about 18. What is the most common value? So we could say the typical value Well, the typical value would be the one that's got the most dots. Remember, that describes the number of dots, tells you how many observations there are for that value. So the highest column for dots would be right here, and that would be at 17. One other thing you might observe is that we have a dot way out here that's separated from the rest, and so that we could call an outlier. We haven't necessarily used that term yet, but you've probably heard it before. It's a term that's just far away, or a term that means that you've got a value that's far away from the rest of them. So we have an outlier at 35 games played. So that's the idea. We want to look at these graphs and just sort of make some generalizations based on what we're seeing visually. Take a look at this example. The following is a dot plot for the cost of mathematics textbooks at Flagler College. This is a fictitious graph, but it's another example of a dot plot. And so some questions they may ask us to answer based on looking at the graph. How many textbooks cost $100 or more? It looks to me, and it's a little hard to see on the graph, so sometimes we have to kind of estimate it. But over here, it looks to me like we have one dot right at the $100 mark. So because it says $100 or more, and I don't see anything past that, I'm going to say there's one dot that represents a textbook that costs $100 or more. What percentage of the textbooks cost under $50? Well, so first of all, how many total are there? If we count the number of dots, we've got 1, 2, 3, 4, looks like 5, 6, 7, 8, 9. I'm counting 11 dots total. And then under the $50 mark, well, the $50 mark would be somewhere, I'd say right in about here. So under the $50 mark would be anything below that. So I would say there's 1, 2, 3 dots. Oh, that last one, kind of missed that one there. But there's 3 dots below the $50 mark. So that means we would have a percentage of 3 over 11, which is about 27%. And then finally, are there any unusually inexpensive or expensive textbooks? So any textbooks or any dots that look like they're far away from the rest of the dots. And I would say there probably is one right down here. And it looks to me like that one is at about $15. And I know that not every dot is labeled exactly, so you're kind of making some estimations here, and that's okay for right now. So some advantages and disadvantages of using dot plots. So some advantages are that it shows individual values. So you can see individual data values. And that's something that doesn't happen with histograms, which we'll get to next. It does help us see the shape of the distribution. Now, 11 in this last example was a pretty small sample size, but obviously the bigger the sample, we'll get a better sense of the shape. So it helps. Let's write that down. It helps see the shape of the distribution. I'm going to abbreviate and say distribution. Some disadvantages. It's not great if you have a lot of data values. So let's say that. Not good for a lot of data values. And that reason is because it's hard. You've got all these, every dot represents every individual observation, but like let's say you had 1,000 dots, that would be kind of hard to see and kind of see what's going on if you have a lot of dots or a large sample. So if you have too big of a sample, a dot plot may not be the way to go. Another disadvantage is tends to be less common. So dot plots tend to be less common than histograms, which we'll talk about in just a minute. All right. So the next way that we can represent numerical data, so far we've got dot plots, now we're going to add histograms to that. So histograms group data into intervals, and the intervals are called bins, B-I-N-S, and the width of each interval is called the bin width, W-I-D-T-H. It counts the frequency of data values that fall into each bin, and we'll see an example of this in a minute. Each rectangle, which shows you the frequencies that fall within each bin. Some properties for that are that consecutive bins touch. The first value in each bin is recorded on the horizontal axis, and the height of each rectangle corresponds to the count or the frequency. So the higher or the taller the rectangle, the more values you have in that particular bin. All right. So to make a histogram in StatCrunch, these are the steps that you're going to follow. You're going to have your data in a column of StatCrunch, and then you're going to go to Graphs, Histogram, and then select the column that you want to plot. And again, we'll go over that a little bit more in class. So on the next page of your notes, you'll see this is the soccer player data, again, the number of games played. And this is a histogram. And like I said, we'll talk about in class how to develop the histogram in StatCrunch. But what I want you to focus on right now are some features you notice about the graph. So how do we read this, first of all? Well, notice that we have these bins. So each bin, it looks to me like it's a width of 5 units. How do I know? Well, in this first bin, it starts out at 0 games played, and then the next bin would start out at 5 games played. So the width for the first bin would run from games played from 0 to 4, and then the next bin, the width would run, clean that up a little bit, the next bin, the width would run from 5, where it picks up, to 9 games played, and so forth. So the bin width for each one is 5 units. And the height of each rectangle tells you how many players fall into that little range. So like the height of the first rectangle is 4. That means there were 4 players who played between 0 and 4 games. The height of the next rectangle looks to me like it's about 5 units right there. So that means there are 5 players who played between 5 and 9 games, and so forth. One thing I really want you to pay attention to is the shape of the graph. Notice that it's heavier in this interval from 10 to about 25. And so we would say that the graph is skewed. We would actually say skewed left, but we'll talk more about that in the next chapter. But what I want you to see is that it's skewed, so it's not a symmetrical graph. And you may notice also that there's something going on over here. So we have this player, and how do I say this player? How do I know that? Because the height of this rectangle over here is 1 unit. So that means there was 1 player who played between 35 and 39 games. So we could say there is an outlier, let's say 1 outlier who played between 35 and 39 games. Now we know it's 35 because remember from the data earlier, we saw the individual data points, we knew it was 35. But if I didn't have the individual data, I wouldn't be able to say that it's 35. All the graph tells me is that there's a player who falls between 35 and 39. And it says, what is the default bin width created by StatCrunch? StatCrunch will usually default to whatever bin width is most appropriate for that data. But you can see the width itself is 5 units. Each one is 5 units long. Now below it says the same data, but this time we've changed the bin width in StatCrunch. So take a look at the next picture. Let's move this up. Same data, same soccer players and everything, but what is the new bin width? Can you tell? Take a look at the data here. So this time it looks to me, so we've got 0 to, it looks like 2 units, right? So it goes from 0, starts out at 0, and then 2, and then the next one starts out at 4, and then the next one starts out at 6, and so forth. So the bin width this time is 2 units. So the first category would be between 0 and 1. The next category would be, I shouldn't say category, let me choose my words carefully. The next interval would be from 2 to 3, and then 4 to 5, and so forth. So the bin width this time is 2. So an important thing to notice when you're working with StatCrunch, and we'll play around with this a little bit in class when we do some of the assignments, but you can adjust that bin width to see more detail or less detail depending on what it is you're interested in. All right. Let's take a look at the next page. A few notes on bin width. So a bin width that is too narrow shows too much detail. And then a bin width that is too narrow shows too much detail. If it's too wide, it might hide the detail. So you're going to want to play around with the bin width a little bit when you're working with these to kind of see what makes sense for the data you're using. The technology will usually choose a default bin width, and that's probably what you can go with most of the time. But sometimes you might want more detail, so you may want to change that bin width yourself. So some advantages and disadvantages of using histograms. So some advantages is that it's good for large data sets. So if you've got a lot of data, you can kind of contain that and manage it a little bit better if you have a histogram versus, say, a dot plot where it shows each individual data point. Another good thing about histograms is it helps us focus on the shape, the general shape of the graph. If it's symmetric or skewed, it's usually really easy to tell with a histogram. It also makes it easy to spot outliers, like we saw that bin in the previous example. Let me show you, let me go back real quick, where it was way out. It's easy to see that visually, that you've got something that's far away from the rest of the data. Some disadvantages to using a dot plot is that it does hide those individual data values. So individual data values, I should say, are not visible. And the distribution shape is affected by the change in the bin width. So like I said, you're going to have to play with that bin width a little bit to kind of get a sense of what works for that data. The last example here I have is for stem plots. Stem plots you've probably heard of before. They may have been called in your past education stem and leaf plots. It's the same thing. Stem plots, just like dot plots, they show individual data values. We're not going to do these by hand. We're going to use StatCrunch to generate them. Without technology, they are useful because they can easily be drawn by hand if the data set is not too large. So I didn't put advantages and disadvantages on here because stem plots really are not as common as the other two. We tend to use histograms and dot plots more often. Stem plots are a little bit more tedious to work with sometimes, but if you've got a small data set, they're not so bad. So to generate a stem plot in StatCrunch, once you've got your data in a column, you're going to go to Graphs, Stem and Leaf, and then select the column you want to plot. So as a quick example here, it says the data below is the New England Patriots 2018 games prior to the Super Bowl. Super Bowl, I think that's 53. So we've got a bunch of games. I think they mean scores. So these must be the scores during their 2018 season. Let's see, there's a lot of games for a football season. I'm not sure. It's a set of data. That's all we need to worry about. So it tells you that a decimal point is 1 digit to the right of the column, and the leaf unit is 1. So, for example, if we take all of this data, here's our stem and leaf plot. So what this means is in this first row here, we've got 2 games represented. So the score for these 2 games would be 1 for the tens column and then 7 for the ones column. So that means there was a score of 17. And then they had another game that they also scored 17 points. In the next column, they had games that were 24 points, another game that was 24 points, another game that was 25 points, another game that was 25 points, and so forth. And you can see some of these, even though the data is out of order. There's your 2 17 games. 25, I'm looking quick. Do we see 25? There's 25. There should be another one in here somewhere. And they're out of order, so it's a little hard to find them. But that's the idea. 26, they had 2 games that were scores of 26, 2 games that were scores of 27, and so forth. Stem plots are not as useful because they don't show shape at all. So it tends to be a little bit more difficult to find shapes, although it is easy to find outliers. Like if I had, let's say they had a game, this is I don't think possible for a football game, but let's say they had a game where they scored 81 points. Down here, you'd see that we would have 8 and then comma 1, just like that. There's not going to be any with zeros because 0 would indicate that that was a 0 in the ones column. So it's not so hard to see outliers, but other than that, stem and leaf plots are a little bit tedious to work with. And so when we're working with numerical data, just to summarize, the 3 types of graphs we're going to look at are dot plots, histograms, and stem plots.